Continue with the problems, right? So take down the second problem. Three charges, each equal to each equal to plus 4 nanocoulomb are placed at the three corners of a square of side 2 centimeter. Find the electric field at the fourth corner. Right? So this is also once asked in the examination. Right? So the given three charges having the same magnitude, that is 4 nanocoulomb. Those three charges are placed at the three corners of a square. So side 2 centimeter. That means square side is 2 centimeter. Right? So if we take corners of the square, right? So we call it A, B, C, and D. Right? So this is the square. So square having the side that is 2 centimeter. So each side they place the charge 4 nanocoulomb. So here also QB that is equals to 4 nanocoulomb. QA 4 nanocoulomb, right? So next QC that is 4 nanocoulomb. We need to find the electric field at the point D. So this problem is also from the charge due to multiple, that is electric field due to the multiple charges. So here we need to find the electric field at D. So that electric field is produced by QA, QB and QC. So here they given this one as a square, so the distance between it is 2 centimeter. So from this is also 2 centimeter. That means electric field due to A, the distance is 2 centimeter. The electric field at D due to C is 2 centimeter, right? So what is the distance from D to B, right? So that gives the diagonal, right? So from Pythagoras theorem, so this is a right angle triangle. So BD is equals to square root of 2 square plus 2 square, right? So this becomes 2 into 2 square, right? So that is 2 root. So the distance BD is 2 root 2, right? So next, first we need to find electric field at D due to A, right? So that is given by ED is equals to, we know the formula, that is 1 divided by 4 pi epsilon naught Q A by R square, that is RA square, right? So this value we know, 9 into 10 to the power of 9 into QA value is 4 into 10 to the power of minus 9. RA distance is 2 centimeter, that is 2 into 10 to the power of minus 2 whole square, right? So now if we simplify, 9 into 10 to the power of 9 into 4 into 10 to the power of minus 9. In the denominator it becomes 4 into 10 to the power of minus 4. So here it is plus 9, minus 9 cancels. So 4 get cancelled. If this minus 4 shifts to the numerator, it becomes 9 into 10 to the power of 4 Newton per Coulomb. So this is electric field ED, right? So as here we are considering always the positive charge. So here is positive and here is positive. So the electric field is in this direction, that is ED, right? So that is along ED. So this gives the magnitude and this gives the direction. right? So next step, electric field due to charge same. So here both the magnitude of the charge is same and also the distance between the charges is same, right? So we get the same answer. EC is equals to 9 into 10 to the power of 4 Newton per Coulomb, right? So if you check means you can substitute and simplify, again you getting the same value. So here the direction is in this direction, that is repulsive force. So here we get EC, right? So that is along CD, right? So next, electric field at a point D due to charge B, right? Right here, that is EB, right? So that is equals to 1 divided by 4 pi epsilon naught cube B divided by RB square, right? So the value is 9 into 10 to the power of 9 into 4 into 10 to the power of minus 9 divided by, so RB is the distance between D and, that is 2 into 10 to the power of minus 2 whole square, right? So here we get 9 into 10 to the power of 9 into 4 into 10 to the power of minus 9 by 4 into 2 into 10 to the power of minus 4. 4 get cancelled, so 10 to the power of 9, 10 to the power of plus 9, right? So here we get 9 divided by 2 into 10 to the power of 4 Newton per Coulomb. So this gives EB, right? So this is along BC. So that means electric field is in this direction. That is EB, right? So now we need to find the electric field at a point D. That means the final electric field E, right? So first we need to simplify these two vectors. So EC is a one vector and ED is another vector. So these two vectors, if we simplify, so here EC and here we have ED. So angle between the two vectors is 90 degree, right? So by applying the resultant, so ECD, right? So this is the electric field due to these two vectors EC and ED, right? So we know square root EC square plus ED square plus 2 EC ED cos theta, right? So here the angle between two electric field is 90 degrees. So cos 90 is 0. So this whole term becomes 0, right? So electric field E CD is equals to square root under EC square plus ED square, right? So we have EC, ED, both have same values. We can write this one as 2 into EC square, or we can write EC into root 2, right? So here we have the value 9 root 2 into 10 to the power of 4 Newton per Coulomb, right? So the direction, if we complete this parallelogram, like the diagonal gives the resultant. So diagonal is, this is in the form of square. So diagonal, here diagonal is 45 degree. That means here we get the resultant electric field, that is ECD, right? So next, so now if you observe here, the electric field at point D. So this is point D. Here already we have the electric field due to B. Again we get one electric field, that is electric field E due to C and B, right? So these two are parallel. EB and EC are parallel. That means angle theta is 0, right? So we can directly add the electric field E is equals to electric field EB plus electric field CD, right? So it becomes 0 means EC plus ED. That means EC here EB plus ECD plus 2EB ECD. This cos theta value becomes 1. So it becomes EB plus ECD whole square, right? So here we get the value of EB is 9 by 2, that is 4.5 into 10 to the power of 4 plus here it is 9 root 2 into 10 to the power of 4, right? So we get value, root 2 value is 1.4, 4.5 plus 10 to the power of into 10 to the power of 4. So 9 into 1.41 into 10 to the power of 4. So 12.6 into 10 to the power of 4. So this value becomes 12.6. So that becomes 12 plus 4, that is 16 or 17.1 into 10 to the power of 4 Newton per Coulomb. So this is the final answer. Right? So lengthy, important for 5 minutes. Right, so understand this one. So here diagram is very important. So without diagram we can't able to solve the problem, right? So always remember the point, if two vectors are in parallel, any vector, if we consider EA and EB both having angle theta is 0 degree, then the resultant electric field E is taken as EA plus EB, right? So two vectors both are in same direction, the angle theta is 0 degree, so from there we can directly add. So no need to repeat again and again to write this formula, right? So in the next case, if those two are in the opposite direction, so if we consider this one as EA and here it is EB, so angle between these two vectors, that is theta is equals to 180 degrees, right? So here cos 180 is minus 1, so it becomes EC minus ED whole square, right? So square and square root get cancelled, the resultant electric field E is equals to EA minus EB, right? So this one is the second thing. And third, if two vectors are in perpendicular to each other, EA and EB are perpendicular, the angle between is 90 degree, the resultant E is equals to under square root EA square plus EB square. So you need to remember these 3 points, right? Right, now the second problem. So this one is an important concept on problems. So one more important topic on problem: 2-point charges, 2 nanocoulomb and 18 nanocoulomb are located at 1 meter apart, are located at 1 meter apart in air. Find the position along line joining the charges, line joining the two charges at which resultant intensity is 0. So this is second type, very important type, right? So in the problem they mentioned two charges, right? So here considering this one as point A and charge QA and another point B QB, charge QB, right? So these two charges are located 1 meter apart. That means the distance between the two charges is 1 meter, right? The given two charges, QA is equals to 2 nanocoulomb and QB is equals to 18 nanocoulomb, right? Next, what they are saying is find the position along the line joining the two charges, right? So this is the line joining. If you draw the straight line between the two charges, then this gives the line joining between the two charges, right? So in the line joining, somewhere here or somewhere on this line joining between the two charges, the resultant intensity is zero. That means if we consider this point as P, so at this P, that means the resultant electric field at P is equals to zero, right? So we need to find the distance. So from here or we can consider from here. That is as your wish, right? So I am considering x distance. We don't know at what distance this point is located, right? So for that reason, I am considering x, that is from 2 nanocoulomb, or we can take x from qb, that is 18 nanocoulomb. Then remaining this distance become 1 minus x. Right? Now, first we need to find the electric field intensity at point P due to charge QA. Right? So for that, EA, right? That is E equals to 1 divided by 4 pi epsilon naught QA divided by the distance is x square, right? So we know the charge QA, right? So EA is equals to 9 into 10 to the power of 9. QA is 2 into 10 to the power of minus 9 divided by x square. So direction is along PB, right? So that means here this is the positive charge, here also positive charge, so there is a repulsive force. So in this direction we have the electric field intensity EA, right? So next EB, at point P the electric field due to charge QB, right? So EB is equals to 1 divided by 4 pi epsilon naught QT divided by, so the distance is 1 minus x whole square, right? So we know QB 1 divided by 4 pi epsilon naught. So QB is, here we will write 9 into 10 to the power of 9 into 18 into 10 to the power of minus 9 divided by 1 minus x whole square. So that is, the direction is along PA, right? So that means electric field is acting here, because this is also positive charge, here also positive charge, so the repulsive force will be takes place, so it becomes EB, right? Now if you observe the resultant electric field at P, we have EA and EB at this point. That means these two electric fields are opposite in direction. Then resultant electric field E can be taken as EA minus EB, right? Because the angle between these two vectors is 180 degrees, so directly we can take resultant electric field at point P, E is equals to EA minus EB. So in the question they mentioned the resultant is 0. That means this value is 0. So 0 is equals to EA minus EB, right? So from this we can write EA is equals to EB. So we know the value of EA and we know the value of EB. So substituting here, 9 into 10 to the power of 9 into 2 into 10 to the power of minus 9 divided by x square, that is equals to 9 into 10 to the power of 9 into 18 into 10 to the power of minus 9 divided by 1 minus x whole square, right? So here 9 into 10 to the power of 9, 9 into 10 to the power of 9 cancels. So 10 to the power of minus 9, 10 to the power of minus 9 cancel. So remaining here, so 2 ones are, 2 9s are, right? So 1 divided by x square is equals to 9 divided by 1 minus x whole square, right? So if you apply the square root for whole equation, we get 1 divided by x is equals to 3 divided by 1 minus x, right? Now 1 minus x is equals to 3x. This minus x shifts to RHS, it becomes 1 is equals to 4x, right? So 4x is equals to 1, x is equals to 1 divided by 4, that is 0.25 meter, right? So this point is located 0.25 meter from charge 2 nano coulomb. So this will be the final answer, right? So this method is very important. So same method will continue in the next chapter also while doing potential. So while doing potential, there are two cases. Here we are considering only the electric field in between the two charges, right? So in potential, if we go same method, we need to solve two times. That is for the two cases. So this method is important, right? Next. So next, fourth problem. ABC is an equilateral triangle of side 0.1 meter, charges of minus 4 nanocoulomb and plus 4 nanocoulomb and minus 8 nanocoulomb are placed at the corners A and B respectively. Calculate the resultant electric intensity at corner C. So last before problem is solved for the square. So here they given equilateral triangle. That means all sides are equal and all angles are equal. So taking 3 points A, B, and take C here. Right? So this is for your convenience. Wherever you can take A, B, C or A, B, C or A, B, C. Right? So given we have three corners. So in two corners at A and B, they place the charges 4 nanocoulomb and minus 8 nanocoulomb. Right? So that means here at A, QA is equals to 4 nanocoulomb and at B, QB is equals to minus 8 nanocoulomb. Right? So here we need to find the electric field intensity at point C. So the given side, that is 0.1 meter. 0.1, 0.1 and 0.1, right? So this is due to multiple charges. Here we have two charges, we need to find the electric intensity at point C. So always we take on the point charge as positive charge, right? So first we can find electric field intensity at C due to B. So that can be written as EB, right? So EB is equals to 1 divided by 4 pi epsilon naught QB divided by RB square, right? So we know values 9 into 10 to the power of 9 into QB, that is 8 into 10 to the power of minus 9 divided by the distance RB, that is 0.1 meter. So 0.1 can be written as 10 to the power of minus 1 whole square, right? So here plus 9 minus 9 cancel. So 8 9s are 72 into 10 to the power of 2 Newton per Coulomb EB. Right? So if you observe here we have the minus charge, here we have the plus charge. There is an attractive force. That's why the electric field is towards this direction, EB. That is towards B, right? So 72 into 10 to the power of 2 Newton per Coulomb along CB. So if we return along BC means it will come in this direction, right? So along CB means from C to B, right? So next, electric field at point C due to charge A, right? That is EA is equals to 1 divided by 4 pi epsilon naught QA divided by RA square. So this taken as RA, right? So 9 into 10 to the power of 9 into charge QA is 4 into 10 to the power of minus 9. So this can be written as 10 to the power of minus 1 whole square. So plus 9 minus 9 cancels, right? So here 36 into 10 to the power of 2 Newton per Coulomb. So direction is, here we have positive charge, here also positive charge. There is a repulsive force. So the direction is in this direction. So this gives E, right? So that is along AC. Now we need the final resultant E, that is due to two electric fields EA and EB. We know the formula. The resultant E is equals to EA square plus EB square plus 2 EA EB cos theta, right? So if you observe here, so this is the straight line. As this angle is 60 degree, right? So we need this angle, that is angle between these two vectors EA and EB. So total angle is 180 degree. So out of 180, 60 is inside the triangle. Then this exterior angle becomes how much? So that is, this angle is 120 degree, right? So here theta becomes 120. So substituting here, so EA, that is 36 into 10 to the power of 2 whole square, right? So EB 72 into 10 to the power of 2 whole square, right? So plus 2 into EA 36 into 10 to the power of 2 into 72 into 10 to the power of 2. So cos 120. So cos 120 is minus 1 by 2. So cos 60 is 1 by 2. So it is obtuse 120, that is cos is minus 1 by 2. So here plus 2. We will divide here. So 236 is 72, right? So now if you observe here, 72 can be written as 36 square. Otherwise, you can overall simplification. If you have calculation, you can directly simplify these values. Here for simplification, 36 into 10 to the power of 2 whole square, right? So this 72 can be written as 36 square into 36 square, 36 into 10 to the power of 2 whole square. Right? So here again plus into minus, minus. So here we can write 2 into 36 into 10 to the power of 2 whole square. Right? So from all these we can take common 36 into 10 to the power of 2 whole square. Right? So here we left 1. So in the second term we left 2 square. In the third term we left 2. Right? So here this will get cancels out. We get 36 into 10 to the power of 2. Right? So it is in the root. 4 plus 1 5. 5 minus 2 is 3. We get 36 root 3 into 10 to the power of 2. We can end up here Newton per Coulomb or The value of root 3 is 1.71, right? So if you multiply that value 36 into 1.71, so we get the final value 6235. Once check this value, 6325 Newton per Coulomb. Approximately we get 6325 Newton per Coulomb, right? So this is for the triangle. One is for square. Here we solve for triangle, right? So one more problem, the same method. Take the problem. Two big balls of mass 10 gram each are suspended by two threads. Each are suspended by two threads from same support or charged identically. They move apart they move apart 0.08 meter and thread makes an angle 60 degree with each other. Find the charge on each big ball, right? So in the question they given here we have a rigid support. From this support, two pit balls are suspended. That means two spherical metallic balls are suspended, right? So these two are gets charged. Initially we have two balls here like this, right? So these two spherical balls are gets charged. That is identically charged. That means these two are positively charged or negatively charged. Identical charge. So if these two are charges, then opposite charges. So due to these opposite charges, they repulse each other, right? So they repulse each other by forming an angle 60 degree with each other. That means they move away. So by how much meters? That is 0.08 meters they move away, right? So making an angle 60 degree, right? So here we need to find the charge Q, which is charged on the pit ball, right? So we need to find the charge, right? So for that, here we have they given the mass of the pit ball. So here the weight is acting, that is mg, right? So this is from the last year topic. Next, there is a force. So which force it is? That is the repulsive force, that is F, right? So next, there is a tension in the string, right? This is T, right? We need to balance this spherical ball, right? So for that, if we draw one parallel here, so this angle becomes 30 degree, right? Now we need to resolve the tension on the string into two components. One is vertical component and another one is horizontal component, right? So by the opposite angle, so here angle becomes 30 degree. Then this force becomes T cos 30 degree, and here it becomes T sin 30 degree, right? So this is at equilibrium, right? Now for balancing force, F is equals to T sin 30 degree, right? So next, mg is equals to T cos 30 degree. So calling this as equation 1 and equation 2. Now divide equation 1 and 2. So we get T get cancelled, sin 30 by cos 30 is tan 30. Tan 30 is equals to F divided by mg, right? So F is equals to mg tan 30 degree, right? So tan 30 is mg, right? So tan 30 1 by root 3, right? So here there is a force of repulsion, that is from Coulomb's law. We call this force is equals to charges here q, and here also identical charge q, right? So the force we have 1 divided by 4 pi epsilon naught q into q. The distance of separation 8 into 10 to the power of minus 2 whole square. So 0.08 can be written as 8 into 10 to the power of minus 2, right? So now if we substitute here this force 1 divided by 4 pi epsilon naught q1, that is q into q, it becomes q square divided by 8 into 10 to the power of minus 2 whole square, right? So m into g, they given mass 10 gram. So 1 gram so 10 milligrams, right? So 10 into 10 to the power of minus 3 grams, and 1 gram is equal to 10 to the power of minus 3 kg, right? So next into 1 by root 3. So here we know all the values. From this we need to find q value, right? So this value becomes 9 into 10 to the power of 9 into q square divided by 8 into 10 to the power of minus 2 whole square, that is equals to 10 to the power of minus 6 plus 1, it becomes minus 5 by root 3, right? So we need q square. Q square is equals to 8 into 10 to the power of minus 2 whole square, next into 10 to the power of minus 5 whole divided by 9 into 10 to the power of 9 into root 3, right? So we need q. So q is equals to under square root, right? So this can be written in the square root 8 into 10 to the power of minus 2 whole square into, so this 10 to the power of plus 9, if it goes to the numerator it becomes minus 9, right? So 10 to the power of minus 5 minus 9, so it becomes minus 14 divided by 9 into root 3, right? So first term square and square root get cancelled. 10 to the power of minus 14 can be written as 10 to the power of minus 7 whole square, right? So 8 into 10 to the power of minus 2 into 10 to the power of minus 7 divided by, so 9 under root we get 3 into 3, right? So Q is equals to 8 divided by 9 into 10 to the power of minus 9, minus 2 minus 7, that is minus 9 coulomb, right? So 8 divided by 9, how much value we are getting? So 0.88 nano coulomb. That is each charge Q 0.88 nano coulomb. Sorry, here we forget one more value. We substitute only M. Here again we have one value G. 9.8 around we can take 10. So then here it becomes minus 6 plus 2 minus 4. So again here it is minus 4. So 9 minus 9 minus 4 minus 13. Simplify here, we can take this one as 9.8. Here it becomes minus 5 into 9.8. Add one more term, 9.8. So into 9.8 into 9.8. So here it is under root 9.8. So 8 into 9 into root 9.8 nano coulomb. Right. So the value we get 6.34 nano coulomb. Right. So these are the few methods on this topics. So all these problems are repeated in the examination. So try to solve these problems. Thank you.